was giving you my background. I work at Panasonic Avionics. We are in IoT space for airlines, and I've been doing this for quite some time. I'm just getting my hand dirty with Microsoft IoT stack. I stumbled upon this Azure Sphere device, which is very good, and I've fallen in love with it. Today, I'm going to talk how to get started using Azure Sphere using a dev kit. This is a very high level talk. I myself am learning. So some of the question, if I'm not able to answer, if you can drop me an email, I will get back to you with those answers. So today's session uh, is I will be giving you some introduction to Azure Sphere, both at the hardware architectural level, what makes up the Azure Sphere ecosystem, then set up the software development environment, and give you some code walkthrough and how easy it is for you to start developing secure IoT system using Azure Sphere. Okay. Any question? Let me know, and if I'm going too fast, you can pause me. So, Azure Sphere is a secure hardware device. It's an ecosystem in itself. It provides you with the hardware certified chip by MediaTek. It provides you with a secure operating system and a closed loop uh, ecosystem that allows you to, get your IoT Internet of Things product to market in a secure, reliable way. And a lot of this information is up on the Microsoft website, and I will not repeat them over here, but I have the links over here, so you can always go through, and I'll share these slides after this talk. So, so I don't know much, like how many people have the background in the hardware over here, but I just pair at the chip level. It's a dual core chip. It has an ARM7 Cortex, and that runs the high level application like it's a a stripped down version of Linux that runs on it, and it has a lot of security wrapper from Microsoft. Then it has two ARM core microcontroller based cores on which you can run your own real-time operating system or bare metal system. I will show you through the demo today. Um, it has a pretty good rich set of peripherals, and I have developed a lot of hardware using the Azure Sphere, and I really like it in terms of having the flexibility of writing a Linux code on this, as well as writing the real-time FreeRTOS code on the microcontroller and talking between the two cores. It gives a good breed of application where you want the real-time performance in one of the core and the a POSIX compliant connected to the network securely and sending the data over securely to backhaul. So, and you can find more information. I have added the links on the um, in this PowerPoint, so you can find more information on how to get going. Any questions so far? So before you get started, there are some prerequisites. You need to have an Azure Sphere dev board, and you can buy it from Amazon or you can buy it from Seed Studio, and you can get one. And also, you need to have Visual Studio 2019 or Visual Studio Code, and then download the SDK. And I have provided you the link over here. Okay. Give the link walks you through how to install the SDK and for different operating system. Today my talk is on Windows. I have already set up my uh, SDK and I have already provisioned my device. And as part of the SDK, you get a command line interface tool, and which I'm going to walk you through today. And that allows you to, in the development mode, configure your device, connect it to Wi-Fi, flash the operating system, upgrade the operating system, recover it, you know, all those things, nice tools, features it gives, So in order to get started, first you have to install the SDK. SDK provides you with a lot of examples as well as all the necessary tools to get started with your device. So I'm going to start demonstrating you with the Azure Sphere developer tools. So very first thing when you have to launch this Azure Sphere developer command prompt, and in this you have to run. This is with Azure Sphere command line interface version 1. There's a version 2 out that has much better, richer set of features. I haven't played with it. So I'm going to just focus on today on command line interface version 1. So first thing you have to do is log into your uh, Microsoft Azure Portal, and because it's all it's a closed loop system. So the device has to be registered, and you have to claim your tenant uh, from the Microsoft Portal. So you guys can see my screen, right? So I have a device connected to my laptop, and I can see. So these are various commands. Device def stand for device in short term. Short. So it gives you all the current operating system that's running on the OS, and I can perform update through this. I can configure the Wi-Fi. So if I say uh, it tells me which this is the Wi-Fi that my Azure Sphere is connected to. So I can now communicate. I can have my program that's running communicate to internet, which I'll should be showing you a demo about of a simple UDP client that will talk to my UDP server, Echo server, and I will be showing that. And there are some caveat that you need to set up, be aware of, and that you need to set up in the permission and all those things. Any questions so far with this? There are a lot of commands over here. The the main command is your Wi-Fi, and if you ever toast your device, you can run device recover. It will recover everything, and then to enable your debugging. Give me one second. Okay. And these two links, when you buy a new device, you have to claim it, because it has, and then it's bind the device to your Microsoft Azure account. So without that, you cannot progress any further. So you have to, and I have provided you the link, and then you have to register the device to your particular tenant in your Azure portal. So I've provided you with the link of a lot of important one where you can download the GitHub samples, um, and your application API libraries and everything. So yeah. The very first thing that you have to do in order to enable debugging is once you claim your device and once you have registered to your tenant, you have to enable debugging. In order to enable debugging, you have to run a command in your Azure thing. Oop, I spelled it wrong. Give me 1 second. I think I have the command wrong over here. So oh, I need to be in admin privilege. So let me start this. So it installed the USB drivers and everything. Now it allows me to step through the code, It takes a while. Any questions or have you guys, has anyone tried to play with it, with this device? Okay. Okay. So I have enabled debugging. So I'm going to start Visual Studio. Uh, so you say create new project. In Azure Sphere, there are two types of application you can write using Visual Studio. One is the high-level core. This is the Linux, all the Linux API reduced subset of Linux. and then there's the real-time core. So you can target, you can create two types of targets. So first demo is about creating the Linux high-level core. So I'm going to select. You see, I'll select the default program over here, and it is the high level. HL stand for high level core, and RT stand for real time core. Okay, there are two different target you can build the application for, and then you can also write an application where you can communicate from high level core into your low level core. I'll show you a demo today, and that allows you to send data from read the sensor data in the real-time core and then send it up to the cloud using the high-level core. So let me go back. Let me do simple Blinky. And the project that you build are all CMake uh, based. So you'll see in every of them all the CMake. I'm not sure how many people are used to CMake, but CMake is basically a tool generator, compile tool generator. Then uh, that generates all the necessary flags and settings for compiler, like the code generator from like Make or Ninja. So I am setting the minimum version over to 310. That's what I have on my system, and my project name is Blinky, and it is uh, C-based project. And this is very important, the version of your API and the API set that you have to put, and then again all your hardware definition that the system generate. There are three flavors of hardware that are there in the market, and the one that I have is called the RDB reference design board, and I also have the module on based on which I can do my own hardware design. And so the important files over here is this app manifest.json. Over here, you have to set all the pins that the application is going to use, all the communication TCP/IP ports, all intercore communication. You have to set over here. Since this is a simple Blinky application, and I am just using GPIO over here, and I can show you how to use the SPI, I2C port, and all those things, and set up this permission. I am using template ID 1. That is the alias or define for GPIO, one of the GPIO. And this is the hardware definition thing, JSON file. This tells the name template LED is matched to is of type GPIO, and it is mapped to the hardware pin that is referenced to as MediaTek processor reference design board LED1 red LED. So if I go into this hardware defined template, I will see that this is mapped to my GPI on the board. This is mapped to my GPI number 8. And the information can be got from the data sheet of that hardware, how the pins are mapped. So when I say, you have to find out which pin correspond to the GPIO that you're trying to set. So um, this is the kit I am using, and the pinout uh, definition you can get it from the data sheet, and that tells you which GPIOs map to which of the headers pin that are connected over here. Okay. So app manifest.json is a very important file you need to be aware of, and this is where you set all your permissions and uh, resources that you plan to use within your application, and all the intercore communication also you would set up over here. And one of the example I will show you today. Okay, this is a very simple program. By default program, it uses the Linux files uh, uh, APIs to write to GPIO, and and to set toggle the GPIO. So that's what it does, and it uses the POSIX timer. So every 1 second it's going to blink the LEDs. So I'm going to put a breakpoint over here, and my target over here is high level debugger core. And you'll see all the output over here. If there's any output that needs to be put out, so, it is blinking. I will turn on my camera. Let me see if I can turn on my camera. It's not giving me control to turn on my camera to show you the blinking of the LEDs. But anyway, uh, any question, guys, so far? Let me know when you guys can see the camera.
We can see it.
Yeah, okay. So you see the LED blinking over here?
Yes, we can.
Okay. So that's a very simple example. Next example, I'm going to show you how to do simple intercore communication. And for that, I am going to open an existing project, and I will walk you through the important aspects of what need to happen. Okay, so open the folder, and let's go to the. Okay, over here, if you look, there are two projects over here. One is the high level application. Second one is the real time application. Okay, And if I open up the real-time application, this is all bare metal. You are at the using you're writing the code directly for the microcontroller. You're not writing the code for an operating system. Over here again, this is a very important file, application manifest.json, and you have to in, in order for the code to communicate with each other, you have to update the capabilities to allow the intercore communication and by using this component ID. So this is the component ID for the application that is running in the real-time core. And this is the component ID for application that is running in the high-level core, the POSEC compliant core. Okay, and I'll take you there. So if I open up this, if you look, let's see how I can demonstrate this. If you look over here, I, from the real-time core, I have said over here, allow application connection to the application component ID this, and it shows over there. So this is a must, in order for you to enable inter-core communication. Okay, I'm going to run this application. Again, you can run a specific core by selecting the debug into specific core, or you can run for all the cores. Okay, so I'm just going to run it by default, and I'll show you the output. These are the messages that are being printed out, sending high-level application, and different thing, and then receive 19 byte in the real-time core. You can see the flow, and it's a pretty straightforward application. I believe it uses mailbox or shared memory to communicate between the two cores. Okay, so if we look at over here, uh, and just using the intercore communication, sending the message across, it creates a socket, and through the shared memory. And if you look over here, it uses the API to do this. So one of the application where I was working, where I needed a real-time communication with a LoRaWAN sensor, I used the real-time code to communicate and talk to the LoRaWAN uh, module, and whatever data I needed to send across to a LoRa network, I would use the real-time core, and whatever message I needed to get from my Azure portal down into the high-level core, and then push it down across. So one of the application I have done using this. You have to get your hand dirty to understand and appreciate, how good this processor is. Especially with very small form factor and low cost, you have ability to run your POSIX compliant application. Any question on this, guys? Okay. the next app that I had in mind was an UDP app to demonstrate, how what are the key aspects in order for you to use the internet protocol like UDP or TCP. So I'm going to show you that. So here again, in order for you to communicate with external app, you have to set up the firewall of your on the Azure Sphere, and you have to specify the IP address or the fully qualified domain name to which you want to communicate and the port that is required over here. This is my dummy server that I'm running over here on in the cloud, and it's listening to port 1709. So, and it's a simple Linux UDP uh, app, and I'll share the code and everything. Simple socket-based app. It just talks to the Echo server. So, echoing back to the server. So it's received, it's sent. So uh, I just had one. I did not put it in a loop or anything. So uh, it sent it in valid format. Slow in responding. Uh, Anyway, that's pretty much it I had for the three flavors of app that I wanted to demonstrate, and to how to get started using this device. Uh, any questions for me?
Yeah, Yash, I have a question. coming right off the box, does the um, device have the OS and the debugger already loaded, or do we have to
No,
download?
no. It has the basic operating system, and so what you would do is use this Azure command line interface,
Mhm.
and you would do AZ Sphere, uh, and if you type in, you get all the high-level command. Then all the device-related command. Then you would go in AZ Sphere. Uh, uh, Sorry, I always miss the keyboard. It's a problem. So you would see over here, and in order for you to upgrade, you would just hit I'll do it for you right now. AZ Sphere device recover. Okay. When you do recover, it wipes out everything. So it downloads signed image, and there are APIs that allows you to when you get into like a large scale, there are APIs that allows you to perform this in bulk. So it is downloading the image, verified image and signed image from Microsoft Portal, and then it's going to burn it down. It's erasing the flash and everything for you, and it'll upgrade it to the latest version of the operating system.
Okay.
So by default, uh, probably you have a little or slightly older version. So in order for you to get started to the latest version to match your SDK, you would uh, use this command, and then I'll show you the Wi-Fi setting also. In order for you to connect the device to your Wi-Fi, and any application you write that requires access to external world, you have to set up those permission in your app manifest.
Okay.
So I'll let it go through, and I will just quickly another 2 seconds. It should be done. It's pretty powerful. I mean, I have used it, and it is very very low power, and it's secure, and it is. It makes life very easy in IoT space, this device, and that's why Starbucks and all have invested in this quite a lot over here. So I have recovered the thing, so I need to now, I can enable debugging by using, uh, if you want to disable debugging in the real-time core, you don't have to use the last word, last flag. But if you use that, it enables you to debug both the core app, so it's installing all the USB drivers and everything. Now this allows you to communicate through your Visual Studio with the Azure Sphere device. And it's pretty straightforward. Most of, if you have done a lot of Linux programming, the high level core is piece of cake. It has reduced set, but they are very, very powerful, especially the real when you're doing with your timings and maintenance and all those things. It is very, very good. I mean,
Is there a version of Python available for the high-level core and the
I
Linux?
don't, I am
Or
not sure. I'm not sure. This is I all C, and I think they were working on C sharp for it, but I'm not sure for Python. You know, so, um, so that's enabled my device for to be able to download the program and all those things. And
Mhm.
let us finish. And if I want to do Wi-Fi, Wi-Fi scan, it gives me all the Wi-Fi. So if I want to say, believe, So if I say it gives me what IP address. That's how you get the device onto internet. So and then through your API you can communicate, but you have to ensure the firewall settings are uh, all set in this application manifest.json, and Microsoft has documented this pretty well. Let me go back to the PowerPoint slides. So let me put it in the
So in the manifest file, let's say you have your an IP address, which is the IP address, the
yeah
outside IP address.
yeah, it's external IP address,
It's
but you can
external
put
IP.
fully qualified domain name also.
Okay.
So it'll work. So and if you have multiple of them, you can put it there too. And so let me go back into the slide mode. So this is if you get your when if you get the device and if you want to play around with it, and it's important for you to get the pin mapping, so that you know where you're connecting to, what you're connecting to. All are I believe TTL 3.3 volt pins over here. And what else? I have put the manifest, and I just wanted to show you something very quick. Yeah, this uh, I'll ask Bill how to post these slides, but I will post the slides with the links. So it gives you all the APIs and just be a POSIX compliant, libraries that you need to you can use, and real-time core libraries too. Any other questions, guys?
There was one question in the chat. Does the Azure part allow for OTA pushing new firmware group of
I think
IoT
I
devices?
Yeah, I think they allow, and this is a closed loop system. It allows you to push your OTA and everything, and securely signed. And that's what the beauty of this is. You control it through your portal, and everything. I haven't seen the chat thing, so let me see.
One other question is there a real-time RTOS, either open source or commercial RTOS available for this
Yes,
process?
yes. There are two, I believe, free RTOS you can do, and Azure RTOS too. They are porting some of this. I have used free RTOS on it, and it works. And I have started to like Azure RTOS too. This is the thread, old. I think Microsoft had bought the ThreadX, thread company.
Mhm.
It is very nice. I mean, I've played with other core using Azure RTOS. It's very easy, and and it has all the safety certification and all. So it is pretty cool.
What was the other one you said? Azure RTOS and what?
Azure RTOS, Azure
Okay.
RTOS. Yeah, I see. I did not see the chat messages, so I will just focus on there. So I'll just go through and see. Does this have? Yes, okay. Yeah. ESP is good too, but this, if you want to do some serious secure IoT project, Azure RTOS, Azure Sphere is a very good platform. It is a very secure. It has hardware root of trust. It is very, very good, and it gives you both the flavors in one chip, the real-time operating system as well as POSIX compliant, and it allows you to communicate efficiently, intercore communication, and Microsoft has made the life very easy. Yeah. Okay, any other questions?
Does this device only work with the Azure? Does it support? Is there support for AWS? This is specifically on
Now,
Microsoft.
you can come. This is closely tied to Azure, but there's nothing stopping you from, since it has like all the TCP/IP, MQTT, and all those things. There's nothing stopping you from interfacing with the other platform. But in order for you to do the firmware updates and all those things,
Right.
it is closely tied to the Azure ecosystem.
Mhm.
But if you want to push your sensor data or thing to AWS, it has the libraries and everything. You can definitely push it through. Like I've been working on real-time indoor positioning, and this is one of I ported my POSIX code, the triangulations code onto Azure Sphere. It allows me to, using the BLE beacons, it allows me to position to find where a particular beacon is, using the angle of arrival. And my code runs on Azure Sphere, but it pushes out to my server in my own cloud.
Okay.
Any other questions, guys? I think we are up on time. I have another session tomorrow. If anybody is interested, it's on Azure Edge. There I will be walking through how to set up an Edge on Raspberry Pi, and then I will be showing you a demo of communication between the Edge device and your cloud. Okay, thank you so much, guys.
Thanks. It was a great session.
Yeah, thank you.